Hello guys, welcome to another episode of XR Talk Show. Today we are going to do Advent of Code, live coding in Wolfram language. And I'm going to do the shortest code possible on Earth. So Advent of Code, day 3, live coding, okay? If you are here, say hi, okay? Shall we begin? Let's check audio, check video, check. Oh, okay, so to the code, Advent of Code. Let's see if we can do it, okay? So Advent of Code 2023, day 3, here is the problem. So you are given a input. You are given a input like that, okay? So let's magnify. So you are given a input, a text file. So let's go to XR Talk Show. Okay, so you are given a input like that, a text file, and what is the problem? Sum up number adjacent to a symbol, even diagonally. Periods do not count as a symbol. So, for example, let's see. Okay, so you are given this text. So, for example, there is a symbol asterisk. So adjacent, so that 467 is part of it. Now 114 is not, because the diagonal is it's one off, and then 35 is part of it. 633 is not. Okay, so you want all the numbers that's neighbor of a symbol character. Now, what are the symbols? So period does not count. And I guess anything else except letters. Again, the advent of code is never precise. So anyway, so you want to get all the numbers adjacent to a symbol. Then you want to sum them up. Okay, so in this example, it says 144 and 58. 144 there and 58. Are not adjacent to a symbol. Others are, okay? So you get all the numbers, but remove 144 and 58. Then you sum them up, and result should be 4361. That is Advent of Code 2023, day 3, problem 1. Okay, so I read this problem yesterday. I thought a little bit about it. It's an interesting problem. What do I want to say? There is okay. Hello, Joman Molina. Hello, Ego. So the problem, my first, I'm trying to actually solve this problem today. Okay, instead of but meanwhile, I want to talk about it. Okay, so the first impression is like, again, Advent of Code, when you program a problem, there is many issues. For example, efficiency, algorithmic efficiency concerns, and storage concerns, efficiency concerns, and also the code elegance concern, or the code readability and maintainability concern. You can't have cryptic code, because if you write a software, web server or whatever, you have to come back to it to add features and so on. You have to maintain it or upgrade the language version, so it must be readable. So you have all these concerns, but with Advent of Code, it's like all those are thrown out because they don't care. Advent Code is just an online puzzle. Whoever has the most splashy, you want a solution that is most attention catching, like a drama, like a clickbait. Oh, Advent of Code number 3 solution. Oh, this language is so weird, also short, also cryptic. Oh, this is the longest solution possible. Then people is gonna thumb up. Okay, that's the nature of Advent of Code. So anyway, this problem I was thinking. So first you consider this text block as a matrix. Okay, so each spot is one space. Those periods are empty spots. So you consider this as n by n matrix. Okay, So the first question is if the numbers are sparse, if this is a sparse matrix, that means there are just a few numbers. For example, you have 10 million by 10 million, these characters, okay? But you only have, let's say, 100 numbers in it. So that would be a sparse matrix, okay? So the first question is whether the numbers are sparse. Because if the numbers are sparse, then your algorithm, if you want to be efficient, you just want to grab the numbers and check each number if they have adjacent symbol, if the numbers are sparse. Alternatively, if the symbols are sparse, for example, you have 1 million by 1 million characters, and you have you have 3 million numbers, okay? However, you only have 10 symbols, 10 of these symbols. Then if that's the case, you want to just pass for the symbols. For each symbol, you want to check if there's a number adjacent to it. Okay, that's a case of if the symbol is sparse. But the problem, advent of code, they never say, they don't say anything like that. So if you take your time, if you take time to make your code, okay, there's another, let me talk about another issue. The other issue is it didn't say what are the symbols. It just say, the advent code you can see here, it just says that period are not symbol, okay? Okay, but what kind of symbol do you have? In this example, we see asterisk, we see the number sign, we see the plus sign, we see the dollar sign. But what if you have a letter? Is that a symbol or not? It doesn't say. And are these all the possible symbols there? It doesn't say. The fucking advent of a code. Okay, I want to criticize it a little bit because for vast majority of people who are doing this, I presume college students or young people or teenagers, they don't have better things to do. But for a professional programmer, your time is better spent. You make a lot of money. When you are not coding, you don't want to code, right? So anyway, I want to criticize a bit because vast majority of people doing this, they never talk about this. I don't think so. You rarely see people analyze the problem, the criticism of the advent of the code, the puzzle, and so on. Okay, so we have the few situations whether the numbers are sparse matrix, or whether the symbols are sparse, okay, or maybe neither, okay, maybe they are just like kind of random. In that case, you say it's a molarized, you write a program algorithm that is most algorithmically efficient for that situation. Anyway, so then the other situation is what are the set of characters for the symbol? It doesn't say. So let's look up our own input. So let's have a look. Okay, so here, so does it include A, B, or C? Let's see. So we are in Emacs, so we can grep for, let's say, find replace. Let's say list matching lines, and let's give a bracket A to Z, and copy that and capitalize. So that's all possible A to Z. Let's see if there's anyone. Okay, it's none. So there's no letters. So judging by this, okay, let's do some text processing. Okay, copy it here. Query replace \dot. That means a literal dot, one or more. Enter replace with nothing. Okay. Ban to replace them all. What? Let's do it again. Okay. Okay. So it becomes so short. Now let's make them one line. Okay. Now again, let's do find replace. Okay. This time 0 to 9, one or more. Replace by nothing. Okay. Replace all. Okay. So now it becomes shorter. Now, so basically that's all the symbols you got. Okay, so good. You see, because if you know, the spec doesn't say what are the set of symbols. So if the spec doesn't say, typically what you can do is you code your program so that you find all possible symbols of any input. If you don't do that, then your solution, if I give you another new input, but with a new symbol, let's say comma, okay, is there any comma? No. You know, I put a comma there, your program broke, you see. But if you take the time to write a generalized solution, nobody cares. Like, you know, your code is slow, you know, so on. So that's some analysis about this situation. Okay, so let's close that. So how do we solve this? So we are going just to assume I'm not going to like create the most efficient whatever. But however, I'm going to try, I'm pretty sure I'll succeed to come up with the shortest possible solution code for this problem, okay? And shortest possible solution, and not care about the generalization, okay? And okay, so okay, how do you solve this? You know, it's not hard, but it's a bit tedious. So there are quite a few ways. Okay, you go through each line, you grab the number, then you see the number has a adjacent symbol. If so, then you put that number into a array. Okay, then you repeat that for every line. Then at the end, you just add up all the numbers in the array. Okay, that's essentially it. Okay, that's you know, enough talking. That's 20 minutes. Let's see if I can actually code it within an hour. I hope so. I'm trying to let me try to be focused on this. Okay, so I advanced the code. So solution. So let's start a Wolfram language. Okay, so yeah, start Wolfram language. Start it. New notebook. Let's put a new notebook here. 3, evaluate it, and let's magnify. Okay, so first of all, you want to get the input. Okay, so the input is this. I'm trying to finish this. Okay, instead of failing. Okay, so we got input. So what do you want to do? So you first of all, let's see, let's just try to solve the problem. Don't worry about efficiency or anything else. So I'm just gonna, you know, I'm going to try to finish this. So even if that means no talking, I'm gonna try to do it. Okay, so let me just string length. Let's see how many characters are there. So I know it's 10 by 10. This is 10 by 10 characters, but each line you have a line break. So that's why it's 111. So you can, the most basic way is you go through each line. For example, we are on line 2, but how do you find the previous line and next line? Well, if you are on line 2, the previous is -1. The next line is +1. Okay, so you pass these lines into a array, string split. So that's one way to do it. Each element is a line. That's one way to do it. And when you are on first line, you check, make sure you are, you know, you don't have go to array 0 or array -1. Same thing with when you are at the end of the last line. So that's one way to do it, but Another way is that you can consider the whole thing as one single string, so you don't have to deal with each line. But how do you, if you do that, how do you find the previous line? For example, this line, what is this character? Maybe that's the 14th character, okay? So that's the 14th character. How do you find the position of the previous line above it? So that would be, actually you can do it without going to the previous line because there are 10 characters per line. So 14 minus 10, right? 14 minus 10. So for example, if this, so actually we can do this backward chart. So let me try to do this, okay? Emac this backward chart, okay? Backward chart character will move the cursor backward, so 14, okay? So if we have this code and we put the code here, actually it should be 14 plus 1 because there is a end of line character. So let's try 15, okay? Copy that. So put the cursor here. If we move backward 15, it should end up there, okay? So, okay, do it. Eval the eval expression, okay? Okay, that didn't work. Why is it? So it moved back there. So let's try. Do it again. Do it again. Eval backward. Oh, okay. So each line is 10. So let's try. Each line is 10. The current position. So actually 10, not 15. Well, plus the end of line, so it's 11. Okay, so let's try it again. Show the pink window so you can see all my commands. Eval expression, paste it, do it. Fantastic. Let's try again. Put it here. Fantastic. You see, so two ways. First of all, you can split string to make each line an array element, or consider the whole thing as one single string. Then when you want to move to the previous line, next line, you simply just move by, increase the index by 11. But then you still need to check if they are out of bound, the index, right? Yeah, okay. Okay, that's it's kind of, okay, we got some thought about that, okay? So the total number of characters is 111, okay? 110, okay? So then, so what's the easiest way? Let me think about it, okay? So now the whole solution is gonna be in one single line, and the function we are going to use is string cases, which I explained. I spent 1 hour to explain this function yesterday, okay? Now you can look at the documentation here. String cases, Wolfram language, magnify, okay? It takes 2 arguments. The first argument is a string. The second argument is a pattern, okay? Like regular expression. So the overall structure is just gonna be string cases. Then just total, okay? Because string cases return a list of things. Then with the pattern, then in the pattern part, you can just say replace it by a number, okay? To expression D, okay? In a pattern, we name one of these, we name the number, we give it a name, n, let's say n, okay? Let's say num. Then here we convert the string, a number string, to actual number, Okay, so again, this string case is return a list, so it's just gonna return a list of numbers. Okay, then we just total it. It's, you know, okay, one single line of code. Now in the pattern part, you see the pattern part, you will include a condition such that if a number is not adjacent to a symbol, that caption that is not part of the pattern. Okay, so the pattern must satisfy a condition such that if this number is adjacent to a symbol. Okay, but this is basically the outline of the solution. Okay, so now let's start to code it. So the pattern will be, okay, so what is the pattern? The pattern is this time let's use regular expression because I'm still more familiar with regular expression. Okay, regular expression, the pattern is gonna be, oh wait, here's the thing. If you use regular expression, then you cannot have a arbitrary function as a condition. So you have to use the Wolfram's string pattern syntax. So that is, that's one of the power of Wolfram language. Because if you use regular expression, then you have to, actually it's kind of similar, but basically you want to apply a function to check the matched pattern is actually adjacent to a symbol. But in Wolfram, the Wolfram string pattern syntax, you can easily do that. Let me show you. Okay, string. So string expression is represent a text pattern. Okay, and the syntax is condition pattern and function. Okay, that's what you want. So the pattern will match first, then if the function returns true, then that actually is captured, otherwise no. Okay, so that is the basic syntax. Let's write it out. Okay, so that's okay, that's a string expression. So first of all, what is the pattern? The pattern is digit character. Okay, the pattern is a digit character, and the function is what is the function? Okay, the function is a bit hard, so we need to write a function. Number is valid. Okay, let's name our function. Okay, let's name our function that valid number q equals to function given a number and whatever it does, return true or false. Okay, so that is a function. Right now it's a dummy function. It doesn't do anything. It just always return true for now. Okay, so in Wolfram language convention, whenever you have a symbol whose name ends in a capital Q, that means it's a question. In the Lisp convention, typically they end in P. P stands for predicate, which came from logic. Basically, it means this function always return either true or false. Okay, so, and in Scheme Lisp and Ruby, their convention is for the function to end in a question mark. Okay, so the reason Wolfram language ends in Q, not question mark, is because question mark has many other meanings. So, there's a trade-off. Okay, so that is our string expression, string pattern. Okay, now let's digit character. Okay, there's gotta be one more digit, not just digit character dot dot is a syntax for one or more, right? Okay, right. Then we also need to give this pattern a name, so we'll just name it num. Okay, so num, then put the parenthesis. So this whole line stands for a string pattern such that the pattern is a digit character repeated one or more times, and it must, this function on that pattern must return true, valid number q. Okay, then if that is so, then this pattern has a name num. We can refer to it by num. Okay, then we want, so once we got that, for that pattern, we return this num string into an actual number. Okay, let's try to run this. Okay, let's run, see if that runs. Please, God. Oh God. Okay, problem. What is the problem? String or list of strings expected at position 1. String cases. Oh, of course. This string cases first argument is input, right? Okay, let's run it again. Problem. String case, string or list of strings expected at position 1 in string cases. Okay, string or list of strings. So why is it not a string? Let's go back to our code. It says the input is a string, right? So why are you complaining? Input, it's a string. Oh, because we are evaluating this. We need to comment this out. So comment that out. And this part we also need to comment out because it's invalid. Okay, now run this. Fantastic. Okay, so let's check. Okay, 467, check. 114, check. 35, check. 360. Okay, it seems to check out. Okay, we got all the numbers. Now the difficult part is to write this function, valid number q. How can you be sure it's a valid? Okay, so this is a difficult part. Now, in order to write this function, we need to know how many characters per line. Okay, so let's do that. Let me just show. I'm just gonna show. Char per line. Okay, so this char per line equals to split string split, okay, input, okay, and split by line break, okay, and return the maximum of just one item. Okay, then we want to get the length of that. So backslash is the postfix notation, similar to the Unix vertical line for pipe. Okay, so we apply string length to that. Okay, so we move that, and also total. Okay, so total chars equals to, okay, so something like that. Yeah, right. Fantastic. Okay, This is incorrect, not 111. Oh, okay. So you see, when you call string split, it always return a list. So in this case, you want the first item of that list. Even if you set 1 here, return just the maximum of 1 item. But it still return a list. Because that way, any function, this is a basic principle in Wolfram language. Any function always returns the same structure. Does not matter what kind of parameters you pass it. Their return structure is always the same. So string split always return a list, even if there's even you say just 1 item. Okay, so to get the first item, you can just say 1. Okay, run it. There it is. Okay, wait. The first part is still wrong. Okay, let's look up the documentation for split string. Find myself at an impasse on day 10. Tiago, advanced day 10 of my journey. I'm hopeful that the deities of programming will bestow their wisdom upon me to guide me through. Oh, day 10. Very advanced. I hope I will get to that. But I'm kind of slow. Maybe that'll become next year. Day 10. Okay, so anyway, so how many days are there then of the code, so this Christian thing until Christmas, right? But anyway, let's focus on the code. So string split, I don't know what's going on. Let's just print it. Okay, let's just see what it is. What? Char lines. Okay, so let's wait, so the split is not successful. What's going on? So do you require double backslash for the I don't think so, but why is it always hate to be stuck. So it just returns the whole thing. Okay, you mean just settling after getting homework? Good luck, sir. Getting home from work. Okay. So split string. Let's just try. Let's just try random. I don't think that's the something is wrong with my code. Okay. Okay, now it works. Oh yeah, okay, so why is it split at most n substrings? Oh, okay, actually you have to say 2. I know, because the first, you see, we actually have a something before, like, there's a difference between that and that. So the actual, it should be like that. So if it's like that, it works. Run it. No, wait. Okay, let's see 2. Let's say 2. Yeah, so you see this should be anyway, should be 2 at most 2 of them. Okay, then you say get the first one, then you say remove that, then you say, yeah, let's just change this to 2. Okay, run it. Okay, so you need to print output. Okay, so char per line is 10, correct? Okay, this is 10, and then the total number of lines is 109. Okay. Okay, right. Okay, so we got the string length. So now we need to do some modular arithmetics. That is, given a position in the string, you see here we captured the number, but however, we also need to know the index of the number, the index within the whole string. So you cannot use string cases. You need the index. You know, you captured the number, but you also need to know the beginning and end of their index, because otherwise you have no way. Wait, maybe there's a way. This is fantastic Wolfram language hacking. So one solution is you get the index, because without index you can't, check if that number is adjacent to a symbol. Okay, that's one way. You get the index, and in order to get index, you need to say string position, I believe. Give a list of starting and ending characters position. Okay. Yeah, so this actually, yeah, so instead of string cases, you use string position to get a list of beginning and end positions for each digit occurrence. Once you do that, you have the position. Then you need to pass the position to where is it? Did I just delete it? Yeah. Then you need to pass your position to this. So actually you need 2 arguments. Okay. The first is a number. The second one is position. Okay, so this function is valid number takes 2 arguments. The position will be beginning and end positions. Okay, so that's one way to do it. The other way now. So if we do that, then we kind of need not string cases but string position. Okay, so kind of like that. Yeah, they have the same syntax. So that's one way to do it. But can we do it without doing the string position? So if we don't have the string position, we just have a number. Let's think about if there's another way, some kind of pattern matching on symbols. So one way is to get a bunch of numbers. Then you also do the same thing, string cases, but this time on the symbols. So you also got a bunch of symbols. Yeah, but how do you know their relative position? Is there a way? Okay, let me think about this. I want to get this done, so I'm gonna just think about it. Is there a way to know the position? I mean, with position, you can solve the problem, but if you don't know the position, is there a way to simply by getting the pattern, a list of all the digits and a list of all the symbols, just by having that, are you able to? Okay, I don't think so. Why not? Well, because the numbers, the occurrence of numbers and the occurrence of the symbols, they have a relation. Only when this relation is satisfied, meaning that they are adjacent, then the number is valid. So this relation is a positional relation, right? So it's a positional relation. But is there a way to, ultimately you have to somehow know their position. But is it possible without using string position? Like, I don't think so. Well, because ultimately you need to know their position. If you just get the patterns, then now is there a way in string cases, in a string expression, to actually return their position? I don't know. So let's just look up the documentation for the string expression syntax. Maybe if we are lucky, maybe it okay, so this is too big. So here are the syntax for string expression. These are string patterns. We want to know, is it possible to also extract the position they occur? Pattern given in the name. So in a regular expression, usually, yes, in a regular expression, when you capture something, in Python or Emacs, usually you have a way to know the beginning and end index where this capture happens. Yes, that's true in Emacs and also in Python. And I presume, I don't remember, but I think it's true in all almost, also in JavaScript. Okay, so you can get the index, beginning and end index of something that matched a pattern. Okay, you can do that with regular expression functions. Okay, so now the question is, can you do that with the Wolfram language string expression? Usually yes, because once because the string expression is supposed to be more powerful. I mean, it's supposed to be analogous to, yes. So now we are trying to find, we are trying to find the pattern we matched, and we are trying to get their beginning and end position, okay? And how do you do that? And in other languages, that's usually not part of the pattern syntax. That is usually either a different function or a method of the regular expression object that return the result, make a regular expression object. Then you can dot begin position or dot end, so it's likely it is true in Wolfram language too. So you need, so the string cases, maybe there's a function. We can look up the documentation. Or another way is we can just say options, okay, at string cases. Let's see. Meta characters none, ignore case false, overlap false. Okay, there is no. What is meta characters? Okay, meta characters is something obscure. Yeah, meta characters is something obscure. Meta characters is an option to string position. With meta characters none, no string have special meanings. With meta characters, that specifies the meta characters for pattern escape. Oh, okay. Single character matching, but why is there no dedicated documentation for yeah, so it's not actually, it's something obscure. Interesting. we found kind of a bug, you see. You know, the page you found cannot be found. So this meta character thing is something obscure, this option. And apparently it's not very well documented. Okay. Meta characters automatic is equivalent to meta characters that. Okay, anyway. It's not relevant to us. Okay, so but there is no how. So the question now is, once you have a pattern, once you captured a pattern, how do you get the beginning and end position? Okay, so that means read the documentation. Okay, so we need to read the documentation for string expression. So this is when I usually take my tablet and walk and back and forth for 10 minutes or something to read the entirety of this string expression documentation. That's what I usually do. So to prevent my ass rot from sitting all day. So anyway, let's read it. Good evening, Jesus settled in maybe this, maybe what? So we want to find the beginning and end position, okay, so of a match, okay. Start of string, there it is. Start of string, start of the whole string, end of the whole string. Wait, no. Those are the start of string is a symbol that represent a pattern to indicate that must start at the beginning of a string, similar to regular expressions correct character. Okay, so that is not it. So let me just read it. Okay, so you see, normally in other languages, in Python, in Emacs, Lisp, in JavaScript, the information about the beginning and end position of a matched pattern is typically stored in a built-in variable. In other words, it's not functional programming, because once you do some regular expression, match it matched, this beginning end positions are stored in a totally entirely different variable. So it's not functional programming. Okay, but still the question is, how do you find it in Wolfram language? Okay. So now we are kind of stuck with this issue. Not really, we just haven't found the answer yet. There are two approaches now. One is the easy approach. Just start to use the search. Search Wolfram. How do I get the beginning end position of a pattern? That's the easier way. Usually I don't like that because I want to demonstrate, I should be able to, I know where to look. But let's just cheat. Okay, so position of match. Okay, let's see string match. Let's see what it says. String and characters, string position, string match Q. Work with string patterns. Okay, that take note, that is kind of a tutorial. Okay, string match Q. From the link, pick range length at input. String match Q pattern at input. So Shiko says, from the link, pick range at length at input. Okay, I don't know what is that though. Let's see. So pick suggests I look into this. The question is, I don't know what is pick. Very interesting. Let's see what is pick. Pick list selection. Pick out those elements of list for which the corresponding element of selection is true. Yeah, but if you do this, a number may be repeated in an input. So it's not necessarily unique. And also, this is inefficient because once you get a bunch of numbers, for each number you have to search through the whole input again to find it, I think. But there's a way to get a position for sure, because live coding, it makes it looks like we cannot find it, but that's not the case. It's just that we haven't really spent time to find it yet. So we want to find, so given once you got a pattern match, you want to find the beginning and end position. Okay, and let me think about how is that done usually. So once you have a match, you want to know the beginning and end position. Again, so let's just check on string expression documentation again. Use ordinary string. Okay, so any string. Maybe maybe you actually just have to use string positions, because you see this function, in Wolfram language, every function is very specific. So if you want a position, use a string position. If you just want to extract the cases, then you use string cases, maybe. Because once we use string positions, then we know the position, then we can easily extract the pattern. So, but it's just, I haven't given up yet to see if there's a way. So examples, okay. Scope, survey of the scope of standard use cases, okay. So you don't care. Use any order to match patterns in any order. Okay, very interesting. By the way, you cannot do this in regular expression. Assign or matching any order to a variable. Anyway, we want beginning and end position, okay? Applications, sample problems that can be solved with this function. Find the primes with 4 identical digits, okay? Find a prime with 4 identical digits, okay? Properties and relations, okay? String count, okay? String free, string cases. Okay, there is one string position. Maybe we have to use string position. Now, if we use string position, then we have to extract it. Okay, so let's move on. Let's use string position then. Okay, let's move on. So check if the code is the same. Yes, okay. The pick, I don't think. Pick is new. Pick is, okay, new in 2004, okay. Let me make sure your suggestion is actually works or not. Pick out those elements of list for which the corresponding element is true. Okay, so it's some kind of, it's like a bit mask. Yeah, I remember I read this. So for example, you have A, B, C, D, E, then you have a bit mask. 1 means pass through, okay, 0 means filter out. So you get that. So you are saying, oh wait, you are saying, I think you are suggesting an entirely new solution, such that we treat the whole input as some kind of, matrix. Then we, I don't know. Oh, actually, wait. That's another approach. So you treat the whole thing as a list of characters. Then you pick out, anyway, that's a new approach. But that's a new approach. I have to think about that. So for now, let's focus on what I'm doing. Okay, so close that. So now let's look at string positions. Yes. Let's just run it, okay? Run it. Invalid, okay? Something is wrong. String positions. Why is it invalid? Now, if string cases, we got something wrong before. Wait. Why is it not working anymore? Too many parameters in num position. Oh, okay. Because this function valid number q now takes 2 arguments. So that is, but here it only gives 1 argument, so it complains. So this is actually should be position. Yeah, that'll work. Okay, so string cases work. Okay, now let's try string positions. Run it. Okay, why is it? Oh yeah, so when you do string positions, obviously you get two expressions. So it returns a bunch of 2 numbers. Okay, so it returns. You don't even need this part. Okay. Yeah. So here is it. These are the beginning and end positions of each number. Okay. Okay, so change your plan. Oh, God. Okay, I need a break. That's an issue with live coding. You can't. Yeah, okay, anyway, so it returns that. Okay, now let's look at that again, see what we can do with string position. So we get a pattern. You cannot actually replace it here. You can have multiple patterns, okay? List of results for each of the string, okay? So you can't fuck. It's just more code. Okay, string. So you get the list of numbers. Okay, so then so you can have a function that you apply that to. That's right. You map this function. Okay, let me just do it. You map this function to. Okay, so let's do this. Positions equals to that. Okay. Now all you have to do is you map this function valid number q to positions. Okay. And here we I know what to do. Okay, let me just code it. So positions. Okay, number positions. So here's a bunch of number positions, and you don't need that. Okay, so this is number positions. Okay, let's shrink a little bit. Okay, so symbol positions. Now we try to get all the positions for symbols. Let's see. Yeah, we can do all the positions for symbols too. Okay. Now let's look at the syntax for string expression. So we want to exclude except digit character or period. Okay, that's our pattern. So string expression except that maybe. Let's test it out. Okay, let's try the Wolfram language notebook because last time it seems easier to read there. Okay, so we're just gonna try some code here. No, okay, except digital character is not a valid string. Oh yeah. Wait, no, you can't use except. Does it take one? Instead of except, let's just say characters. Okay. Okay, now let's look at our input. Let's just see. Yeah, wait, where's our input? There. Copy, new buffer, paste, back, copy the file path. It's okay. So go back here. Okay, so now let's read string. Okay, that's this file is the user input. Okay, now let's look at the user input. Let's remove, like we did before, remove all numbers and remove digit. Okay, so then that's all the possible digits. Now we want to, that's all the possible symbols. Okay, so now we can do, let's use Wolfram language. Okay, close that, close that, close that. Okay, copy. Let's use Wolfram language characters. Okay, that will return all the unique characters. Okay. Oh no, it doesn't delete duplicate. Okay. Let's just do this. Okay, so close that. So delete duplicate, delete all duplicate from a list. Okay, so characters input then okay, that's what we want. So first of all, input that reads in the input. Now S, yeah, we misspelled characters. Okay, so unique chars. Okay, so that is a list of symbol chars. Okay, let's try it again. Yeah, wait. Okay, and yep. Oh, and you got digits. Stupid idiotic digits. You gotta remove the digits and remove the period. Okay. What you can do is replace string replace. Okay, string replaced, right? So string replace input and by a pattern. Okay, so let's see if that works. No. String replace. Oh, you need a rule. So those becomes empty string. Yep, and here you need double backslash. Wait, no. string replace one or more digit characters, and replace one or more period. Okay, this is getting long and longer. No comment. Okay. Yeah, but I want to finish this. So string replace input digit characters. Why is it not matching? I don't understand. Why is this? Maybe. Okay, I'm just like doing trial and error now. The worst way of programming. Okay, that kind of worked actually. So now so why is the backslash not working? Oh wait, so it's not followed by, right? This means followed by a string expression. So you want or, so let's use or. I don't know. No, that's not. Okay, it's no, because we. How do I read of the period? It's very odd. Period, one or more. Why can't I remove period? Ah, fuck. Where am I? Okay, now the input is too big. Now let's try the original input. Here. Okay, now let's try now let's go back to the syntax for string expression. There is a or pattern here. A pattern matching at least one of the pattern. Okay, so you can either use or list. Okay, so you use a list. Okay, so you can use a list here. Okay, and remove the paren. So it's either a digit character or one bunch of period. Okay, the period removal, it failed. Just the period. Fuck, I'm so idiotic. I've been brainwashed by the regular expression backslash thing. So a period in a string is just a period in the Wolfram string expression pattern. So this pattern means a digit character, one or more, or a period, one or more. Replace them by empty string. And actually here we can just say rule instead of rule delay. There it is. And also replace space, okay? Space, replace new line. Okay? So the number of patterns is very small. I mean, the number of symbols is very small, okay? So you got that, put that. So this gives you a you see, the possible symbols are just that, okay? So okay, let's write it down. God, now it's almost 2 hours. Anyone else is watching? Say hi. Okay, this is another. So we got the input, we got unique symbol characters, a list of unique symbol characters. Not many, it's just 4 of them. Asterisk, pound sign, plus, and $sign, okay? Then chopper line, okay. Hello, Lendron. Great. Yeah, actually I need a break. God, the element except. So where is this except? Oh yeah, it's symbol position. Let's remove that. So symbol positions. Okay, so symbol positions. Now we know what are the symbols. So unique sim chars. So it's just it's actually just that, okay? Let's see. Okay, so what is this? The first part, then something invalid, okay? Character is not valid, okay? So we got the syntax error, some code we are not using there. So yeah, so here is wrong character. Yeah, so remove that, okay? Now run it again. Let's see what we got. Okay, so we got the big line, one single line. Okay, let's see. Go to the top. So we got an input, we got unique symbol characters, a list of characters, okay, like that. Then we got chopper line, okay, we got total number of chars, okay. Then we don't care about now this function we haven't implemented yet. Valid number, whether it's true or not. Number positions, this what does this do? So input string expression number positions. Let's see. String cases, let's comment that out, okay? So now we just got number positions. Let's see if that's right. Okay, so it's one giant big of numbers, okay? Now let's go back to let's not read our long input. Let's just use the toy input. Okay, so the number positions. Okay, so 1 3. Yeah, okay, that's the position of the number. The first number 1 3, second number. Okay, wrong. 1 3 and 2 3 and 3 3. So it's actually, you see, 4 6 7, then 6 7, then 7. Okay, that's not what we want. So the number positions here is incorrect. Okay, this number positions is incorrect. Make sure that's what we see. Yep. So the number of positions is incorrect. Okay, we can evaluate it here so you can see 1 3 2 3 3 3. That's not right. So here is a question about pattern matching, whether you want to match maximum or minimum. Okay, which is an issue. But usually it's longest. Why is it string positions? Okay, let's see string positions. Let's look at the string positions documentation and options. Okay, overlap true. We run into that before. Ignore case true. Yeah. String position returns sequence specifications in the form used by string take and blah blah blah. Okay, give position substring matching. Okay, yeah, so it gives okay. Yeah, and biosequence. Okay, it does not mention. Okay, so what we have to do is we use the longest, which is the default. So why is it yeah, this is problematic. Let's just try this string positions. Let's just try it. Okay, string positions, string number. Okay, and okay, so let's see what that returns. Yeah, you don't want the semicolon because the semicolon suppresses the output. Okay, so 5 7. God, this is not good. 1 3 2 3 3 3. So it wait, so is the overlap true or false? God, so many. Ignore case, overlap true. We want overlap false. Okay, we don't want overlap. There it is. We so many tricky details. Okay. Okay, string position. So that overlap false. Okay. God. Okay. Now run it. Now better. Let's check. 1 3, yes. This 6 8. Okay, looks right. Then 25 26. Yeah. then 29, 33, 31. Yep. Okay. Good. Finally got that part right. Lendra says, Wolfram seems like a very complicated language. Kind of. Well, I would say, that depends. It's very different from other industrial languages for sure. But I would say it's actually, so if you are an alien from Mars, you don't know anything about Earth or human beings, but you are intelligent. You just came from Mars. Then you drop to Earth. Then let's say you are given, let's say Java, Python, Wolfram language, Haskell, Lisp. You start to learn them in parallel. Okay, which one would this alien find the easiest? I would say that would be Wolfram language. Okay, that's my view. It appears very complex because it's very different from the vast, the common industrial languages most people are familiar with. C, Java, C++, Python, they all basically do the same way, Bash, so, but however, if you are fresh and new, I would say, yeah, I'm pretty sure. I would say it's Wolfram language is actually simpler. Okay, back to the problem. So we got a list of positions. We got a list of number positions. Okay, and now since we found a problem about the overlap, now we need to do that for the symbol positions as well, because if we don't, let's see what it returns. Oh, so it so happens symbols are never consecutive. It's interesting to find. You see, symbols are never consecutive. But, if day one is any indication, maybe in a real input, it sneaks in consecutive symbols. Does it actually happen somewhere? I don't know, but you see, symbols so happen to be never consecutive. But it is actually something we have to look out for, because the problem does not say that symbols never occur together. You see, that's a thing about advent of code. But from the look of it, it looks like the symbols are never adjacent to each other. But anyway, just to be sure, just to be safe, the correct solution is to not assume that symbols are never adjacent. So this is the better. Let's run it. You see, okay. So let's run them two. Let's run two accounts. One is symbol overlap true, other one overlap false. Let's see, and this time let's use our input. So let's see, copy new buffer, paste. So we got two of them. One is 149. Okay, so it's hard to tell from this output they are the same or not. Okay, but what you can do is that you can say equal. Then you so we can see, let me show you. Equal. Let's see if they are equal or not. they are equal. So actually the symbols never happens consecutively. Interesting hidden shit. Okay, so anyway, overlap force. Okay, we want overlap force. We don't assume the symbols never overlap. Okay, so we got number positions. Now then we got symbol positions. Now we need to write this valid number. This is actually the heart of the problem, and we spend almost 2 hours. We haven't write this code yet. Actually, it's good time for a break, because usually when you take a break, you can look at some other approaches. Then usually, instead of you slaving into the details like this, you might find a better way and solve it easier. But or we can just push on, and let's just push on. I mean, we are making a lot of progress. It's not like we are stuck somewhere, right? So now we need to write the valid number. The valid number is the valid given a position, beginning and end position. So what we have to do is, we need to write this function. So the body of the function will be basically the algorithm will be check if there is a symbol in front or after the number. Then check if there is a symbol above the line. Then check if there is a symbol after the line. So 3 lines we need to check. A symbol in front of a, so first of all, let's check if there is a adjacent Lendra says, turns out that in a superfunctional language like Wolfram, you need to write a gazillion functions just to replace simple loop for C. That's false. That's patently false. The one thing with doing live stream is that, you see, why do I have all these functions? I don't need to. If I'm actually just coding it myself, you won't see all these functions. But then nobody would understand what I'm doing. You see, and also I use this long form. There's a lot. Also I write them such that I went out my way to write them in all this way, so that the readers, you guys, can understand what I'm doing. Because normally you don't write things this way. And also I'm writing these extra variables, just so that mostly it's for that purpose, So in fact, if you code Wolfram language, you can look at the previous 2 days solution. There's no extra function outside. This is like the whole solution is one single line, one single expression. There's no even definition of a function, one single expression within 200 characters for each event of code day. And I would say for all advent of code, in fact, for the entire history of advent of code, any of its problem is one single line of Wolfram language in, within, let's say, 500 characters, the entire history of advent of code problem. And further, I would claim you don't even have to define one single function. You might think I'm exaggerating. I'm not, because that's the nature of Wolfram language. It's it's a term rewriting system. In an academic computer science way of speaking, it's called term rewriting system. You don't need, but anyway, so that's kind of getting. So anyway, let's go back to kind of addressing these issues gets me energized, but I'm not solving the problem right now. So we need to. I'm tired. Sitting here for like 2 hours now. We need to write this function. So so check, you just have to check each line. So given that, so let's start with the easiest case. So now I'm thinking, is there a way actually without checking positions at all? You simply use some kind of pattern matching such that without knowing any position about anything, but you simply use some string pattern that will match your number only if it has one of these symbols adjacent to it, even above it or below it. You see, because now we took the time to find out all the symbols there is. There's actually just 4 of them. So is it possible to write a string pattern such that you don't even need to know the position? It is actually, it may be possible. And also, Shiko made this suggestion, this pick that's very interesting, that I need to think about. That actually might work, because that pick solution is just like a mask for this matrix. Like you just put the mask onto it, and whatever shows is just the numbers you want. So, but I have to think about that. But right now I'm thinking of, is there a pattern such that, is it possible to write a string expression pattern such that it gets a number only if the number has symbols adjacent to it? So in order to do this, you need your expression, you need your text pattern you need your text pattern to embed information about the entire line plus let's take the number 633 here. So if that is the case, then you need a regular expression that covers this range. Okay. So let's take the number 58. Now, a regular expression for this case will cover this range. Okay. What about 617? Okay, a regular expression covering this case will be in this range. Okay, so basically including the diagonal. Okay, so let's think about this possibility. You're gonna generate a regular expression such that why am I not using the glove 80? I talked about in my last video. Okay, you guys should watch my video, because this I got a light switch for this one. Watch my video 2-3 episode ago, okay? You'll see. I'm gonna use this for a while, for a few months. So anyway, that's another approach. Very interesting. You use the regular expression instead of position checking. Okay, so that's an approach for us right now. Now, the traditional approach would be, now once you get the beginning and end index, you minus the number of characters per line. So you check if there is a symbol occurring in that. Yeah, so maybe this is actually simpler. So all you have to do is you check if there is so suppose our index is, let's say, uh, 27 and 23 and 27. Okay, let's say that's our beginning end. So you just check, is 22 is a symbol, something like that. Okay, so let's suppose begin is position 22 as symbol. Then is position 28 a symbol. Okay, so that's checking the current line. And if you do this, you also have to make sure that you are not, you are not going to the previous line. You have to make sure your number is not at the beginning of the line. Okay, that's God. Then once you do that, then is position 22 minus line chart count, something like that. Okay, so if 58 is a number, you minus line chart count minus 1. Okay, is position that. Okay, so first 1. Okay, let's replace. So this is, so we write down what we are doing. Okay, so y. Okay, make sure the number. So now this x minus 9 is then okay, then is something like that. Okay, this is getting tedious. And also we need to make sure, we need to double check if our number occurs in the first line or the last line. because that way, okay. Okay, we need to make sure we don't step out of the index boundary. Okay, so that is the basic algorithm. If we take this approach, seems problematic. So right now this problem, is been working on this for 2 hours now. So far the code is not much code actually. So far it's like this line. You don't need variables. You don't need special. You can combine them. They become very short single line. And right now we are basically just having 3 lines of code, because this unique, for example, unique symbol characters, do we need it? No, because advanced of code, they don't care. You can manually find out what symbols you need, so you can just hard code into your program, so you don't need this line. Chopper line, we found we can find it out programmatically. That's what we did. But also we can just hard code it. For the real input, the number of characters per line is more than is 140 characters, right? So they are all 140 characters each. So yeah, so we don't need this character per line neither. So it's 140, and the total number of characters, we don't need it neither, so we don't need that line. And this valid number function we do need, which we have not complete yet. Okay, then this number of positions we do need. Yeah, number of positions. Let's give you all the beginning end positions of occurrence of numbers, and we can we shorten it? Yes, we can. We can shorten it by a lot. And symbol positions, do we need it? It's nice to have, because otherwise you have to, yeah, it's actually nice to have. Once you have the symbol positions, you don't have to compute each time. But actually now, thinking about this who is this Shiko's solution about this pick now is looking very attractive. The pick. So let me think about this, because if you do this, you kind of just mask out, like a bit mask on this entire character matrix. So we have, consider this input as a character matrix. So let's see if the pick, how does it work? List selection. Okay, so list selection. Yeah, so you take this string, input string, you replace all numbers by 1, right? You replace all digits by 1. So you got 111 here. And that's right. Then you just pick, okay? Then what you get is a string that contains nothing but numbers. Okay, then what you get is a string like that, but all characters are removed except the numbers. Okay, it's very nice. Then you can do can you do that actually? So yeah, so that's right. Yes, you can do that. Okay, but instead of a string, the input must be a list. That's also easily done. You just convert a string into a sequence of a list of characters. Okay, then so now we get so when you do the pick, we get a list of digits, and the non-digit, we need to replace them by, they just become empty list. They just become empty list. Oh God, I need to think about this. Okay. My wife cut my hair 2 days ago. So I want to finish this problem. I'm thinking of quit the live stream, but yeah, so we can have a matrix. Fantastic, right? We turn this input string into a matrix of characters. So a 2D matrix that will remain the shape of the input string as a rectangle. And each element in the matrix will be just a single character. Okay, then we generate the mask by, it's fairly easy to do, by one of these we just check if a character is a digit or not. We check each and every element of the matrix. If that character is a digit, then it remains. If it's not a digit, we replace it by 0 or something. We can do that without this pick function. Okay, so but once you do that, what do you get? I mean, what is the advantage? What does it do for you? So we work with a 2D matrix. Each element is a character. We are able to filter out any character that's not a digit. Okay, so and retain this matrix shape, and we are also able to filter out any character that's not a symbol. But the question remains, how do you know if a number is adjacent to a symbol? Okay, and the basic solution is like we went through here. The basic solution is to tediously check the position, blah, blah, blah. But is there some kind of like from the top bird's eye view, some kind of mask or net that simply lets you, like a cookie stamp, that easily tells you a number is adjacent to a symbol? So we are trying to look into that using this pick function, and this pick function turns a string, a rectangular string, into a 2D matrix. But is it necessary to turn it into a 2D matrix? Not even. I don't, I think you can work with strings directly. So the question is, what is the advantage of working with matrix? There's probably some advantage, because string is by nature not a structured data structure. With matrix, you can easily pick out, the second row or the third column, things like that. So with matrix, it's much easier to work with. With string, you can't, unless every time you split the lines, Yeah, okay. So matrix, great advantage. Now, back to the problem. Is there some kind of way, like a cookie stamp, that just trivially tells you if a number is adjacent to a... Oh, yes. I think so, yes. With a matrix, given any element in a 2D matrix, you can find all its neighbors. This is the power of Wolfram language. Okay, so given a 2D matrix or even 3D matrix, given a matrix, given any element position of a matrix, it is mathematically defined. Usually in math you need to do that, to find all the neighbors of that element. Okay, to get all the values of adjacent elements. I believe sometimes you need to do that for matrix. So this becomes a traditional math problem, right? So now, if I'm doing this on my own, I would be looking into all the matrix functions. Okay, let's look for a few. Select criteria. Okay, no, let's see. There is a matrix, working on matrix guide. Okay, conditions, numerical data, elements of a list, handling arrays of data. I know where to look for, but okay, let's go there. So data analysis, data manipulation and analysis, array manipulation. Okay, maybe it's there. And symbolic, there is a section that directly addresses matrices, linear algebra. Okay, but we can hire mathematical computation, polynomial algebra, linear algebra. There, let's go. Tensor, right, exactly. So now we got close to the matrix section. Okay, so right now we want a function that, given a index of a matrix, find all its neighbors. Okay, cross norm, total, normalized, projection, orthogonalize, table, identity matrix, diagonal matrix, close. Okay, parts of matrix. There it is. Diagonal position, upper triangularize. Okay, we are. I think I'm fairly sure this is the right way. I mean, this is kind of the simple way for this problem. This would be a spectacular way to solve this problem, and this would be unique. Well, except other programming languages that does mathematics that focus on linear algebra. But otherwise, compared to vast majority of programming languages, this would be unique. Okay, so part of matrices, how do you extract just the? I know I can, I can do it, but it's just that, is there a specific function? I know I can do it even without. Right, all you have to do, just, yeah, I know I can do it, but is there a built-in diagonal to get the list of elements on the diagonal? Okay, so that is the diagonal matrix. Give the list of elements on the leading diagonals of matrix. Okay, that means like that. So this gives the kth diagonal. Okay, so you can use this part of this. You see, this here is an example. You can, so that gets you the diagonal. Okay, so band. Let's see what is band. Band represents the sequence of positions. The sequence of positions on the diagonal band that start with ij in a sparse array. Okay, in a sparse array. Okay, so create a band diagonal matrix. Okay, so but we don't want the entire, we just want the neighbor. So normally in mathematics, that's called, that kind of neighborhood is called von Neumann neighborhood. Okay, because when you have a grid, you can define the neighbors by just vertical or horizontal neighbors, or you can also include the diagonal neighbors. Okay, so von Neumann neighborhood is, okay, the von Neumann neighborhood of four neighborhood cell is classically defined on a two-dimensional square lattice and is composed of a central cell and its four adjacent cells. Okay, so the one I'm looking for is Moore neighborhood. Okay, so now just search the word Moore. So Moore neighborhood includes not just vertical and horizontal, but also diagonal neighbors. Okay, now go back to Wolfram language documentation. Let's just search for Moore if it's got anything. Pseudo inverse, Drazen inverse, pair. Okay, box matrix. Oh, is that what we want? Box matrix. Corner neighbors. There is promising. Let's look up box matrix and corner neighbors. Corner neighbors is an option for various array and image processing functions that specifies whether diagonally adjacent corners should be considered neighbors of a particular element. Exactly. You see? We're getting close. So corner neighbors is an option to some functions, okay? So corner neighbors, if false, that means do not include diagonal, right? Which is von Neumann neighborhood. Now, if corner neighbors is true, that means includes diagonal neighbors, which is Moore neighborhood, okay? Now we just find out, okay, great. Now there is a matrix example. So 8 connected components, morphological components. Oh, maybe morphological components is what you need. I don't know what is that. Oh God, box matrix, there it is. Chessboard distance, Manhattan distance. That's like a CAPC driver. Manhattan distance is a distance defined such that you can only go from one point to another by traveling vertically or horizontally. So normally if you have like 2 points of a triangle, you can just directly go there. But with Manhattan distance, you have to go like that, always like a square. So anyway, I think we are very close. So what is a box matrix? Box matrix. Now remember, our goal is given a matrix, we want its neighbors, okay? We are close, okay? So we have diamond matrix, cross matrix, oh, okay, getting close, and disk matrix, what do you... Structure matrices and convolution kernels. That's related to machine learning, I think. Okay, so diamond matrix gives a matrix whose elements are 1 in a diamond-shaped region that extends our index. Okay, we care about extracting elements, not generating matrices. Okay, the answer is somewhere, is close, okay? Cross matrix. Cross matrix gives a matrix whose elements are 1 in a centered cross-shaped region that extends R positions along each index direction and are 0 otherwise, okay? So basically across, yeah, so but what we want is actually, we just want a function that gives us the adjacent index. Actually, we don't even need a built-in function because yeah, it's just, to get the adjacent index, you just x minus 1 plus 1 and y minus 1 plus 1. But then you need to do boundary check. That is the tedious part. You need to know if you are at the beginning of line, or beginning of row or end of row, or the first row or last row. So boundary check, that's the tedious part. So that is why we are trying to find a function that does it already for you. Okay, disk matrix. Okay, these are not. We could, we could use some of these. So let's go back to let's go back to the. So which function uses corner neighbors? Let's see. So related guide, mathematical morphology. What is that? Combining methods from set theory, topology, and discrete mathematics. Mathematical morphology provides a powerful approach to processing images and other discrete data, okay? So it's primarily for processing images, I suppose. Let's see, search morphology. Morphology is linguistics, so why, I don't understand, why do you have, what is mathematical morphology? The Wolfram language includes an extensive and efficient implementation of mathematical morphology. I'm not sure I've seen that before. Fully integrated with the Wolfram language's general image and data processing. Okay, but it seems mathematical morphology is basically about image processing and data science, maybe. Oh, there's Wikipedia. Okay. Mathematical morphology is a theory and technique for the analysis and processing of geometric structures. Oh, this is new to me. Based on set theory, lattice theory, topology, and random functions. Mathematical morphology is most commonly applied to digital images, but it can be employed as well on graphs, surface meshes, solids, and many other spatial structures. Okay. It's a theory and technique, okay, for analysis and processing of geometrical structures, okay. Topological and geometrical continuous space concepts such as size, shape, convexity, connectivity, and geodesic distance were introduced by mathematical morphology on both continuous and discrete spaces, okay? Mathematical morphology is also the foundation of morphological image processing. It's some deep topic, which consists of a set of operations that transform images according to the above characterizations, okay? Now let's see what is this. A shape in blue and its morphological dilations in green. Okay. And erosion in yellow, okay, by a diamond-shaped structural element. It looks like it's two people dancing. So, so mathematical morphology is analysis of an image processing, and so I'm supposing it's trying to find out what this image is. It's a silhouette of two people dancing. So one of the part of the technique is kind of just add the outline, in these fancy words: dilation, morphological dilation, and erosion, okay? So history, okay, so basic operations. Okay, it seems kind of like newish kind of thing from the past 20 years, maybe. Kind of newish field used by mostly, I would assume, image processing. Okay, so, but this is getting away from what we are doing. Okay, so anyway, this is mathematical morphology, a section of Wolfram functions related to that. And does it have anything to do with our problem? Not really. Well, actually, that's what we are trying to do. If we look at our problem from a geometric point of view, we consider this as a geometric shape. That's what we are doing. Then that's why we have these questions about neighboring elements, and that is why indeed it's some sort of mathematical morphology issue. So okay, I'm just random talking now, to I'm just talking, so there's some video. So actually, to solve the problem, is actually code. Just start to code this tediousness. I don't want to. So I'm pretty sure there is a function. Okay, we just need to find the function that extract the neighboring elements. I'm pretty sure. I'm pretty sure in Wolfram language there is a trivial way. Okay, with a trivial way to such that given a matrix, 2D matrix, and given a index, 2 numbers for item in the matrix. So given these, you can easily have it return all the neighboring values of that entry. Okay, I'm 99% sure that there is either a built-in function or it's so trivial to write it yourself without having to check, these boundary conditions, like, whether you are going beyond the current row or whatnot. Which is not actually difficult to write neither, because all you have to do is just, but it's tedious. Like you have to make four checks. You have to check if your line is the beginning, the first row of the matrix or the last row of the matrix, and you have to check if your element is the first element in a row or the last element in a row. Neighborhood matrix, thank you. So is that the actual function name? No, I don't think. Wait, is that neighborhood? Okay, there's quite a few neighborhood thing. Neighborhood contraction. Okay, let's just search for, let's get neighborhood. Interpreter type, natural language name of a neighborhood. No, I think it's just one of those matrix functions. Okay, it's just here. I can, if I'm not doing this video, I can probably already found it by now. But it's in one of these matrix constructing matrices, table array, coefficient array, construct a matrix from a system of equations. Okay, sparse array, construct a sparse matrix from position and values. That no. Okay, no more. Convert the sparse matrix to ordinary form. Band, give values on any collection of bands or tridiagonal matrices. Okay, this is actually center array. There it is, center array. Create a list of length n with the element. Create a list of length n with the elements of A at the center and 0 elsewhere. Okay, somewhere, okay, somewhere here, very it's one of these. It'll tell you exactly how to do it. I'm pretty sure. I'm like 99%, okay, or something trivial like two functions combined. Band. So what is band? I haven't. Okay, band ji represents the sequence of positions on the diagonal band that start with ij in a sparse array. Okay, it basically represents a diagonal line. So here, okay, maybe here. So band I min, j min, I max, j max. Right, so you can, okay, maybe band, okay, so span diagonal, okay, so there's also minus, maybe extract. Shit, there it is, extract, maybe, probably. Let's look at extract and let's look at minus, okay. Let's see. Extract the part of expression at position specified by position, okay. Okay, so is there a neighborhood option? Okay, I think I'm gonna quit. I'm just gonna quit. Minus gives the minus of a matrix, okay. So minus of a 3 by 3 matrix, what does it do? Oh, it's like doing this computation. Abjugate. So is it matrix operations? Okay, that's what I was looking for. Matrix operations. Pseudo inverse, row reduce, null space, matrix rank, no. Transpose, no. Conjugate transpose, no. Lower triangulize, no. Upper triangulize, no. Symmetrize, no. Diagonal, get the list of elements on the diagonal. We can use that, once you get we can use that. The thing I'm looking for is to avoid boundary check myself, you see. So diagonal can do that. It automatically avoids boundary check because it's gonna give you the diagonal elements. Then you just take, one of each side. Then you get your diagonal. I'm pretty sure there's a option to give you the other diagonal, right? Yeah, but it's still tedious. I want like one single function away to just get all the neighbors, okay? So determinant norm, abjugate minus permanent, Kronecker product, no, matrix power, and I'm kind of like just wasting time here because what really I need to do is actually just code. And it's not that much code anyway. Yeah, because I want to go. Adjacency, okay, let's see, there's adjacency, disk matrix. Let's just try adjacent first. Adjacency graph, adjacency list, adjacency tensor, adjacency matrix, adjacency hypergraph, delete adjacent duplicate, amazing. 7,000 functions built in. Adjacency list gives a list of vertices adjacent to a vertex. Now this is graph theory. Yeah, okay, so this is talking about graph theory. A list of vertices adjacent to the vertex 1. So yeah, that's there it is, table highlight graph. Okay, so maybe this can be applied to this could, I mean, that's something. So there is adjacency matrix. Adjacency matrix gives a vertex adjacency matrix of a graph. Okay, it's related to graph theory. So if we want to apply this to our problem, we have to do something. But it's not what we want for sure. Adjacency tensor, compute the adjacency tensor of an arbitrary hypergraph. Okay, they are talking about graph theory. And this is, someone wrote, this is a library of a function. You can just call, and Wolfram language will dynamically fetch this function in real time when it's executed. So this adjacency tensor. Now, who wrote this? Jonathan Gerard. This is one of the greatest young physicists, Jonathan Gerard. He's doing the Wolfram physics research. Anyway, adjacency, yeah. So, but this adjacency matrix is doing something about graph related. So I don't think so. It's then we have to read it. I think it's related to what we want to do, but it's not exactly. In order to use this, you have to do something. So graphs and matrices. Okay, adjacency tensor. Okay, that's it. Thank you guys for watching. I'm gonna go offline, and by tomorrow you'll see the shortest solution on earth. Classic. What? Henrik says, why YouTube doesn't tell me when you are streaming? I check the bell icon. It simply doesn't tell me when you are start streaming. Yeah. Google is heavy censorship. All kind of nasty, dark things going on. So that's why I recommend Twitter. Okay. Bye guys for today. Thank you guys for watching. Meanwhile, so I recommend Twitter. And I recommend you pay Elon Musk like $8 a month to get a blue check. Okay, I highly recommend, because Twitter is right now, Elon Musk is saving America. So America is collapsing, kind of going down the drain. And there's a good chance that Elon Musk is reviving, it's making America great again. Okay, thank you guys for watching. 2 hours, close to 3 hours. It's kind of disappointing I didn't do it. I hate to, yeah, but that's how usually I do things. Okay, bye guys.